I wanted to add this picture really fast. I'm not actually going to be calling out any of my current, previous, former, or future employers, but if anyone's in this hotel, they've seen this interface right here, and I thought that was pretty timely, so yeah. Let me go ahead and introduce myself just real quick. Anthony Frehner, find me on GitHub, Twitter. I'm also a core team member of the single SPA front-end microservices stuff. I'm also not going to spend a lot of time talking about that today, but I am going to talk about something very related to front-end microservices, which is horrible interfaces, right? Anyway. So what we're going to be doing today is building 5 different horrible interfaces really quickly, just going over them. And it's actually going to all be in vanilla JavaScript and HTML. And I'm also going to provide CodePen links for all of these. And so these are, not only are the interfaces horrible, but I'm going to probably guarantee that the code itself is horrible. So it's a good opportunity for you to go out and fork it and actually make it good, especially when it comes to accessibility and things like that. So the goal of each of these interfaces is going to be make changing the volume as annoying as possible. So some of you may be asking yourself, like, why would I want to do this? And the first reason is that I am really unoriginal. So I was just browsing the web one day, and I came across this collection of GIFs of these really horrible interfaces, and I knew that that was my calling in life. And I didn't have to design them or anything, so it was great. The next reason that I wanted to talk about or do these interfaces is because I wanted to learn things that I don't get to use every day in work. So I saw these interfaces as a way to kind of stretch myself and challenge myself. And my hope is that there is a little bit of something for everyone here. It probably not for like the true 10x developers, but for the rest of us, I hope I touch on something that you go, oh, that's cool. I didn't know how to do that. So how is this going to work? I'm going to start off by showing you the GIF and letting it play once or twice. And then we're going to kind of pretend that we received this horrible interface as part of our day-to-day jobs and kind of figure out what the user acceptance criteria for it are. Then I'm just going to really briefly highlight some key points and difficulties that I came across. And then finally, I do ask you to please be patient because, like I said, these are things that I tried to stretch myself on, and I can guarantee that you can do it better. And so please just go out, fork it, and at me at Twitter. Say, hey, I made this better, and I will love you for it. Another key point is that none of these were built in React at the moment, so if you want to challenge yourself and convert them into React components, that would be cool too. So with all that introduction started, let's actually look at the first horrible interface. Once again, I'll let it play once or twice and try and be thinking of what the requirements are for this. All right, so hopefully you got the idea, right? So I'm going to say these are the requirements that I thought of when I saw this GIF. First, we're going to have to go to 100 digits of pi in order to turn the volume up the whole way. The next thing we're going to have to do is include the period. It was a part of the GIF, and I'll actually explain how that helps us out in the future. But we're going to cheat and just include the period or the decimal point. And then probably the most important part of this GIF is if you make one mistake, you have to start over. You can't correct your mistake. Sorry. So real quick, here's some key takeaways. My first thought was, hey, I'll use math.py for this. But then you put it in your console and you're like, that's about, 85-ish digits short of what we're looking for. So, all those 64-bit floating point numbers and stuff like that. So let's actually end up using a string for it. And that's actually where the decimal point comes in, is like, hey, the string includes the decimal point. That works out nicely for us. So we killed 2 birds with 1 stone on that one. The next thing that we're going to really quickly have to learn about is how to control HTML5 audio with JavaScript. And this is something that we'll be using in all the next horrible interfaces, so it's a nice, good foundational thing to learn. So if you haven't done it before, you can just put in an HTML audio tag and give it an ID, and then you select that audio tag by ID, and you can just do player.play, player.pause. And then also the volume is just on a 0 to 1 scale with decimal point numbers being the in-between numbers. So, like I said, here's the code pen for all of the people that want to go and play around with it at home. And let's actually just play with it here. Who here knows pi really well? We're going to go 3.14159265, and then I always fail on this one. Anyone? 3, 5, 9, 8. Oh, all right. So that's pretty good, though. That's the furthest we've gotten. All right. Cool. Moving on to interface number 2. Give you a second to look through it a little bit. It's pretty standard, right? I feel like this is the future of the web right here. So we're going to have to simulate gravity and have the volume change faster or slower depending on the incline level. Next, I'm going to say that you can't drag the dot itself. That's cheating. That's a good interface. We want horrible interfaces. And then finally, we want both sides to be able to be draggable, and I'll kind of touch on that in a minute, why that's important. So, some key takeaways. We have the input type of range built into the browsers, and that actually gets us like 90% of our interface, which is really convenient. It gets us that dot and the line, and we can just change the value dynamically, so that's great. Then what we're going to have to do is, on mouse down, we need to save the initial Y position of the mouse. And then on mouse move, we compare where the current location of the Y position of the mouse is, and using that delta, we can actually just feed that straight into CSS's transform, and that will just keep that input box rotating directly in line with our mouse. And that's pretty simple, so not too bad. The problem with that, though, is that it only rotates one way. So if we click on the right side and drag up, the right side goes up, but the left side goes down. But if we keep that same logic, we go up with the mouse, but the other side goes down. So we're gonna have to fix that. Fortunately, it's also fairly simple. If you get the midpoint of that input and say, hey, if it's more than the halfway point, just give it that normal number, but if it's less than the halfway point, multiply that number by a -1, and the rotate value will then track where you're going with it. So, not too bad. Here's our code pen for future reference, and let's play with it real fast. All right, not too bad, huh? Sweet. I can see you all, thank you. I can see you all just like itching to go and implement this in your like YouTube and Netflix and stuff like that. Whoa. Okay, so this one, I lied, is not actually a GIF, so I'll give you a chance to read it real fast. But it pretty much just says, make a noise as loud as you want the volume to be. Pretty straightforward, right? Okay. It's actually a great idea. So what we're going to have to do is listen in on the user's microphone. Then we're going to have to pause the music if it happens to be playing while we're recording. Because otherwise we'll get into like a positive feedback loop where like the sound that's playing gets picked up by the microphone, and you can never like quiet the music, right? It's just a positive feedback loop. So pause the music, and then we just kind of want this one to work. And let me explain what I mean by that is the docs for the HTML micro APIs are pretty rough for beginners like me. On top of that, I'm not really good with sound terminology such as frequency, gain, analyzer, stuff like that. And then finally, some of the APIs are deprecated, but yet they're the only ones that are really well supported across all browsers. And then they're also the only ones that are like all the tutorials are written in. And so, oh well, we'll just use the deprecated ones then. But with that said, let's talk about some key takeaways. The first thing we're going to have to do is ask for microphone access. And that's actually pretty simple. It's built into the browser, and you just say, get user media, audio true, and the browser goes through the process of asking for microphone access and permissions and stuff like that. And if you can succeed, then you can move on. And then we're going to build or create a new audio context. And what this audio context does is kind of like the foundation for all of the future like APIs that we're going to be using and dealing with this microphone. So for example, 2 of the APIs, and not all of them, but just 2 of them we're going to talk about, is use that context and we create a media stream source. And that allows us to get access to the stream of sound from the microphone. In addition, another one is like context create script processor, and that allows us to work with that stream inside of JavaScript. I'm probably explaining these all wrong too, so once again, look for the real professionals, the real 10x devs. But once we have that script processor, we can create an on-audio process, and that just gets fired repeatedly as the microphone is recording, and we gain access to the volume of the microphone. So all we do is we just remember the loudest point that it got over like a 4-second period, and stop recording and set the volume to that. And so we're going to try this one out as well, and I'm going to ask, first of all, should we go loud first or quiet first?
Quiet.
Quiet first. Okay, let's see if we can keep it at 0. Okay, we got to 8, so not too bad. It's kind of tough, right? All right, shall we get loud? Can I have all your help to get loud? Let's see if we can get to 100. Ready, set, go. Yeah! That was great. All right, works pretty well. Medium. Okay, we'll try medium real fast. Yeah. Oh. Yeah, that's about the level of enthusiasm that I heard when I walked up here. Just kidding. Whoops. All right, we're on to the 4th one. Should be playing here. There we go. Okay, pretty straightforward. I do this all the time. I don't know. So we're going to have to be able to drag a moon around the sky. We're going to have to calculate the percentage that the moon eclipses or covers the sun. And then we're going to simulate an eclipse and darken the sky. And then finally, an important part is we don't want to let the moon leave the sky. It's not like we're building horrible interfaces, but I just don't want the user to be able to like drag the moon out and then not be able to change the volume again. So let's talk about some key takeaways here. For fun, and once again, this was to challenge myself, I wanted to use the drag and drop API on this. Technically, I didn't even need to. The same functionality could be implemented using just mouse down and mouse move, but I wanted to try it out. So once again, there's another opportunity for someone that's good at these things to go fork the code pen and improve it. So on drag start, on the moon, we need to set some initial data. And we'll talk about why we need that data in a second. But we're going to save the mouse's XY position and the moon's XY position. Then on drag, which is also like mouse move, we're going to absolute position the moon by changing its top and left to whatever the mouse is. So that's great, but we have a problem. If the mouse starts in the middle of the moon, and then we set the moon on the first move, it's going to jump down to where the mouse is, which isn't a smooth experience. Once again, we're building horrible interfaces, but not like janky interfaces. Come on. We have standards, all right? So what we're going to do is use that initial data that we talked about before. And so we set the new moon's location equal to the initial moon's location, plus the mouse's current location, but then we subtract the initial position of the mouse, and that gets us there. Whoops. Finally, we need to calculate like how much are we actually eclipsing the sun, right? So this is the part where you can go back to your high school math teacher and be like, hey, I finally used math in my day-to-day job. It's pretty simple, right? We need to calculate the hypotenuse of a triangle. And if you remember from 2nd grade math, I think that's about right. I don't remember, honestly. To get the hypotenuse of a triangle, you have to do a squared equals b squared plus c squared. But once you get that hypotenuse, or that red line that you see, then we can start doing that. The next thing we do is we get the radius of each circle. And for convenience, I set the radius of the moon and the sun to 50 pixels. And so if we get 2 times the radius, in this case it would be 100 pixels, and we subtract the hypotenuse, or the length of that red line, and that ends up being greater than 0, then we know that the eclipse is happening. So for example, if our 2r is 100 pixels, and our hypotenuse is 95, 100 minus 95 is 5 pixels, and we know that we actually have 5 pixels of eclipse or overlap happening. And so we can take that value and put it directly into the volume. And we can also eclipse or make the sky darken by using CSS's brightness filter as a cheap way to do it. So there's our code pin for it, and let's play around with it real fast. This is kind of a fun one to play around with. I like to try and sneak up on it, like, oh, maybe from this side. Anyway. Thank you. All right, this is my final horrible interface. I know we're all itching to go out and have some dinner, so I'll try to keep this short, but let's see if you can figure this one out. All right. Just everyday stuff. Love it. Okay, so some requirements on this one. We're going to have to drag some dots around in order to draw numbers, right? Then we're going to have to drag a rectangle around the numbers that we drew in order to capture them. And finally, we're going to have to somehow recognize that number and set the volume to it. So, how are we going to do this? The first thing we're going to do is we're going to use Canvas to draw the dots. And actually moving the dots around is going to be pretty much exactly what we did in the previous horrible interface. So we can just copy and paste there. In addition, we're going to cheat on the dots. You see, Canvas has this feature called hit regions that makes interacting with Canvas elements way easier. However, it's not well supported by browsers. In fact, it's so well not supported that you have to enable a flag in Chrome and Firefox in order to get it to happen. So, not that great. At the same time, the purpose of hit regions, as far as I can tell, is that it's supposed to help add accessibility for Canvas elements and items. And also for our purposes, it adds almost like an on-click event type handler for Canvas elements. So it makes that a lot easier. So I don't know, I hear rumors that there's people at Chrome and standards committees here. So maybe, I don't know, hit them up and be like, hey, how about those hit regions, huh? Maybe if you get a chance. But yeah, we're going to use that. And the API for it is really simple. So once you draw your item on the canvas, you just say add hit region and you give it an ID. And that just makes it so much easier. So that's our cheating for the dots. The next part, though, is how are we going to recognize the number? Fortunately, just like any modern solution in any tech company, we're going to use machine learning, right? Why not? It solves everything. I know some of you were thinking blockchain, but yeah, that's the other one. So we're going to use some TensorFlow, and we're going to use a model that was already trained to recognize numbers from pictures. And so let's talk a little bit about what the TensorFlow model or API looks like. The first thing we're going to have to do is load that trained model. And I went out and found a model that was already trained, but this model was only trained to recognize single digits. So this is a part where I think that someone who's really good at TensorFlow and has the time could build a model that recognizes double digits, so 25 instead of just 2. So here's how we load it. It's a promise-based API, so that's great. You just give it a URL to your model. The next thing we're going to have to do is somehow feed TensorFlow just that one little area or rectangle that we drew on the canvas, and not the whole canvas itself. So fortunately for us, Canvas has this built-in method that allows you to copy from one canvas to another really easily. So you create a new canvas and you get a new context, and you use the draw image API. And you give that draw image API the original canvas, and then you give it the dimensions of the rectangle, and it just automatically copies it for you. You don't have to do anything else. So that's a great API. Finally, or next, we need to give that image that we created to TensorFlow, and fortunately for us, it's built in. It recognizes canvas elements natively, so thank you, TensorFlow devs. Woo. And then finally, we just say, hey, make the prediction, or in other words, tell me what number do you think is on this image. So here's our code pin, and let's play around with it. Due to time constraints, because this really is an annoying and horrible interface, I've already drawn some numbers, but if you want to come play with it, oh, whoops, my mouse is a little off here. I may actually have to refresh the page and draw one. Uh-oh. Oh, I know, so bad. Now you really have to commiserate with your users. I'm almost there, I promise. Hey, do we have any life tips? This could be another 25 minutes or so. 11? I'm almost done here. All right. We're going to hope that this creates or recognizes the number 7. So let's play our music here. And hey, all right. Not too bad. The fun thing about TensorFlow, let me pause this. The fun thing about TensorFlow is you can feed it garbage data too, and it'll be like, oh yeah, I recognize that number. Yeah, that's a 1. Okay, sure. Thanks, TensorFlow. And that is actually it for my talk. Here's a link to the collection of code pens. Once again, feel free to just tweet at me if you want to make improvements or anything like that. But thank you for spending some time making UX horrible with me.